See, Lindelof videos, inverse trig practice problems. So we talked a little bit about some stuff we had to know. One, that arc sine and inverse sine have the same meaning, don't they? We also talked about the fact that when we diagrammed it, when we look for the solutions here, that the solutions, this is crucial, that the solutions had to come from this part of the unit circle, from negative, let me do this, from negative pi halves to pi halves. We even took time with our unit circles and we relabeled this, didn't we? Because if you write 7 pi halves or 7 pi thirds or 11 pi sixths or whatever, that value doesn't fit. The values for your answer have got to fit this criterion right here. So look, let's try one here. Let's try one here. You'd think I knew where that was. So what about this? Arc sine of square root 3 over 2. Let's do this. Here's our square root 3 over 2. Square root, wow. Square root 3 over 2. Square root 3 over 2 is greater than negative 1, yes or no? Is it less than 1? How would you know? Well, what's the square root of 3? Square root of 3 is less than what? Can we agree that the square root of 3 must be less than 2? Because square root of 4 is equal to 2. So we have a number less than 2 over 2. Can we agree that's less than 1? So that worked out, didn't it? So, okay. So then we're going to go looking. So we've checked to make sure that this condition is true. And this condition is true. Now we're going to go look for a sine value that's square root 3 over 2. So sine value square root 3 over 2 is here, isn't it? So corresponds to pi thirds. To pi thirds. True? Yes, since what? Since sine of what? Sine of pi thirds is equal to square root 3 over 2, right? So let's try this one the same way. I'm going to take this value, negative square root 2 over 2, and put in here. Does it fit here? It does. How do I know that? Because square root of 1 is 1, so this number here is greater than 1, isn't it? So that works. And now back to the unit circle, and we're looking for opposite square root 2 over 2. We're only looking in this yellow area. Opposite square root 2 over 2 is here, isn't it? And its corresponding angular value is negative pi fourths. So I know, I keep going the wrong way. Is negative pi fourths. This is true. Why? Because sine of what? Sine of negative pi fourths is equal to opposite square root 2 over 2. It's good proof, isn't it? This one's a trick, isn't it? Because doesn't this look like an angular value? But Sky, it can't be an angular value. I know it can't be an angular value because I'm taking the inverse of it, right? And this is, what's the value of pi approximately? 3.14-ish, right? And 3.14-ish over 3 is greater than 1. So it doesn't fit here, does it? Right? I'm just doing that test. Square root 3 is greater than or equal to negative pi halves. Well, yes, that's true. It's less than 1? No, because this is kind of 3.14 over 3, which is greater than 1, isn't it? So, right? Is not. So for this answer here, what I would write is not defined. This thing is not defined here. So not defined. It's not defined here. All right? All right. right. Nicole told me to thank you all for watching. She told me that if you have any comments, please make them. And she wanted me to remind you that if you haven't already subscribed, please subscribe.